The foundation of modern physics rests on an illusion of smoothness. At the Planck scale limit, reality consists of a vibrating cloud of discrete, unconnected points. For decades, the attempt to unify general relativity with quantum mechanics has stalled. The mathematical friction between these two models stems directly from a single shared assumption: the existence of a continuous spacetime manifold. This assumption of a smooth continuum was cemented in early 20th century theoretical physics, but the geometry of space requires an underlying mechanism to generate it. The infinite fractal descent theory discards the concept of a spatial container. There is no pre-existing void waiting to be filled with matter. Instead, the universe operates as a reality graph. Geometry is reconstructed moment by moment through awareness loops executing within a computational substrate. To solve the unification problem, we have to stop treating spacetime as an inert stage. Physical reality functions as an actively compiled algorithm, generated frame by frame. If space is discrete, time operates outside the concept of a continuous flow. The universe processes state changes at an absolute update frequency, a baseline interval known as the universal tick. Time progresses as an acyclic sequence of binary state nodes. These are distinct frames of existence. This requires a strict mathematical distinction between prime time, the absolute universal clock, and the delayed rate actually registered by localized agents. Every physical observer functions as a localized sampling rig. The variable J represents inherent desynchronization, or jitter. Observers capture the universe's state slightly out of phase with the underlying update rate. Applying this discrete update sequence to resolve Zeno's paradox, motion occurs through sequential coordinate shifts rather than the impossible traversal of infinite spatial fractions. Under this framework, a quantum state has either been fully calculated in the current tick or it has not. Intermediate continuous states do not exist. Since time is an update frequency and space is a graph, physical matter requires a precise algorithmic definition. We must identify what mass actually represents within an informational regime. A spatial volume functions strictly as an algorithmic bounding box. Its minimum step size is governed by Planck limits. Within this volume, a particard exists as a localized branch of a fractal. It executes high-frequency internal loops within the span of a single universal tick. This relationship is defined by the fractal density hypothesis. Mass is derived by dividing the recursive depth, n, by the spatial volume, v. By increasing the internal iteration count inside a fixed space, the local density of interactions multiplies. This dense clustering of calculations manifests as the property we measure as mass. Physical matter exists entirely as a high-density pocket of informational recursion trapped inside a localized geometric frame. This dense recursion introduces a structural problem. An incredibly high iteration count places a massive load on the processing cycle of the surrounding local area. The result is computational drag. The local algorithmic substrate struggles to complete all high-density internal loops before the next global tick triggers. This processing lag translates directly into a temporal stretching function. Local time dilates in response to the density of the informational loops. The equation dictates strict proportionality. As interaction density increases, the effective cycle length physically elongates. The system requires more prime time to process the localized data. This precise computational lag serves as the hidden mechanism driving gravitational time dilation. The extreme algorithmic complexity of massive bodies forces localized awareness loops to process slower relative to the universal baseline clock, generating the exact curvature effect we measure as gravity. A mechanism must exist to stabilize these dense calculations and prevent a high-frequency loop from unspooling back into scattered raw data. Physical four-dimensional stability requires the 720-degree orthogonal lock. A wave must circle itself twice through two interlocking rings spinning at 90 degrees. Holding a wavelength in constant recursion through this dual spinning lock creates a stable geometric vertex. This recursion establishes the illusion of solidity. Once these localized structures achieve stability, they must still exchange data with distinct adjacent fractal depths across the reality graph. Interaction relies on phase parity matching. This mandatory synchronization protocol aligns the temporal waveforms of discrete subparticles. Electromagnetism operates as surface-level wave chains to execute this function. Radiation acts as the active handshake protocol, enabling phase synchronization. Mass remains a locked internal calculation, while radiation provides the external data link, ensuring absolute synchronization across the informational regime. Applying these mechanics to macroscopic scales eliminates the mathematical failures traditional physics encounters at the core of high-gravity objects. Under this framework, a black hole operates as a fractal star. It forms an informational bottleneck where extreme pressure pushes recursive depth towards its absolute mathematical limit. As matter compresses, the iteration count accelerates. The density approaches infinity, threatening to exhaust the local processing capacity of the substrate. To prevent a systemic error, the substrate triggers frequency up conversion, forcing a parity symmetry breaking phase transition. The ultra-dense structure finally hits its processing threshold and violently bursts outward, transitioning into macroscopic quantized knots of radiation. Singularities of infinite density are computationally impossible. These informational bottlenecks exist to recycle low-frequency mass into high-frequency radiation, enforcing the absolute conservation of information. This recycling mechanism scales up to the ultimate cosmological extreme, the initial genesis event of the entire system. The Big Bang acts as a universal upconversion event, a global metric signature change where a vast quantity of information simultaneously transitioned phases. This technical map shows the cosmic microwave background. Its radiation profile matches the expected data residue of a swapping zero-state regeneration. Serving as the artifact of the substrate's initial boot sequence, this pattern represents the moment the system state was regenerated for the first frame of existence, leaving a permanent frequency imprint across the reality graph. The total mass accumulation that followed this reset is determined by Lempel-Ziv complexity and a systemic variable known as the creation knob. Tuning this variable condenses the informational substrate into mass. By discarding the continuous manifold, theoretical physics transitions into information engineering. Modulating phase parity and the creation knob provides a direct, actionable, algorithmic method for managing the force of gravity.